In July 2020, the N+ Group launched its vision for green aluminium, setting out 9 principles to lead our industry into the low-carbon economy by developing a new asset class, green aluminium. We followed this in January this year with the most significant announcements on sustainability we have ever made. First were our industry-leading targets for greenhouse gas emissions reduction, with a clear ambition of achieving net zero emissions by 2050, plus a very stretching 35% reduction by 2030. Next was the success of our new generation of inert anode electrolyzers, allowing us to produce the lowest carbon aluminium ever created, tantalizingly close to net zero. We also said that in September 2021, we would publish a detailed plan for our pathway to net zero. Well, here it is. We have rigorously stress-tested these proposals, consulting with a wide range of global stakeholders, customers, and outside experts. But let's be honest, genuine decarbonisation isn't easy. It will be a real challenge, and implementation will only get harder. But that won't deter us. Decarbonising power sources represents about 60% of the potential emissions savings in the aluminium industry. But we already have more than 98% of our aluminium made in smelters using clean, renewable hydropower. So we are not exactly replete with unpicked low-hanging fruit, and we've had to look hard at the entirety of our global production chain to get to a credible route to net zero. Fortunately, a green business can also be an efficient business, and so we will squeeze out every efficiency to be made. But we also can't dodge the fact that transformation on the scale we are proposing will also require massive investment. Therefore, the group is embarking on an ambitious new cycle of investment with an unprecedented programme of capital expenditure. This will make us not just fit for the new sustainability standards of the 2020s, but ultra-competitive in a future world which can't afford to produce carbon at all. At our smelters, which are about a third of our emissions, all of our new plant, built or modernised as part of this investment programme, will be inert anode ready. So we can begin to ramp up production of our groundbreaking zero-carbon aluminium the moment technological developments allow. So other consistent themes in this report include our continued commitment to our industry-leading new energy modernisation programme. This aims to upgrade the hydro power plants of the Angara and Yansi HPP cascade with a view to further increasing the energy output from the same volume of water passing through the hydropower turbines. We will also work to decrease electricity losses during transmission from generation facilities to the actual production sites. This report also covers the whole gamut of our worldwide operations and focuses on issues including reuse and recycling, shipping, the use of solar power and potential hydrogen, plus how we responsibly deploy nature-based solutions at scale. It is very clear we can't do this all on our own, so the group is working in partnership with other organisations across the globe to decarbonise our hard-to-abate industry. Much more needs to be done, and this plan will change in the light of experience and new data. But the commitment to net zero is unflagging. So let me conclude my opening by stressing that the N+ Group is on the threshold of a decade of unprecedented investment to achieve a level of unprecedented innovation. For the last 10 years or more, we have been the world's largest producers of low-carbon aluminium. Now, as the critical importance of this metal is increasingly recognised, we will double down on that worldwide sector leadership and, in so doing, help drive our whole sector towards a net zero future. But we want nothing less than to be the first and largest global producer of zero-carbon aluminium. It's a hell of a challenge, but we have a plan, and it's here in this report. Now, let's hear some more from my colleagues.
To sum up our climate change strategy, it involves actions across the whole value chain. Aluminium production process starts with mining, and we mine for bauxite, which is aluminium-rich material, a mineral, in the form of aluminium hydroxide. There are about 29 billion tons of this mineral in the world, and that will be mined, if the current rate of extraction stays, for about 100 years. And the mining itself takes about 2% of our total greenhouse gas emission. Then there is refining, and refining involves taking the bauxite, crushing it, grinding it, and mixing it with small amount of water. And that produces thick paste. And then it's heated with steam to remove the most of the silicon contained. And that involves 60% of our emissions. Next, there is a smelting. And alumina comes to a special reduction cells with acrylic heated to 950 degrees Celsius. And there is electric current of about 1000 amperes to break the bond between aluminum and oxygen. And that would produce directly 25% of our emissions, and the power needed also takes about 2%, whereas in the world it would be around 65%. The rest, including shipping, is about 11%. We go by each element of our production cycle with modernization, and whatever cannot be reduced or eliminated, then there is a compensatory measures. Thus, by 2050, we will be a net zero producer in terms of greenhouse gas emissions. Our experts will walk you through various stages, but let me summarize. We're going to go through all production facilities under Scope 1 and Scope 2 in both metal and power segments. And we are going to concentrate on several measures. First, which is our primary focus, is abatement. Second, there is avoidance of emissions. And third, there is a compensation. Talking about abatement, from 2030, we'll start reducing our emissions at smelters by using so-called pre-baked anode technology. And aluminum refineries will be using natural gas and LNG where it's applicable. From 2040, we'll be converting to inert anode technology. And aluminum refineries will be using either green hydrogen or electric power from renewable sources. Then, let's not forget that we'll be continuing to enjoy the benefits of low carbon hydropower. And this will be our avoidance program. We launched a new energy program, which is a very good example and a success story of this. Mikhail will talk more about this. Whatever we cannot eliminate through technology, for this will be compensation. There we'll be investing directly in the nature. Anton will talk more about this element. And now let's hear a bit more from experts regarding what's happening in various stages of our production processes.
Hello, I'm Trisha Makati, Corporate Environment Engineer at Windalco. We are reducing emissions across our operations to achieve net zero, an ambitious goal embraced by our 90,000 employees across 5 continents. At Windalco, a bauxite and alumina production facility in Jamaica, we use an open cast method to extract bauxite, which lies close to the surface. Our operations include a shipping port and several farms. We're looking at projects to both lower GHG footprint and reduce cost per ton for our operations. Windalco has also looked into measures to reduce the GHG footprint of its ancillary facilities. For example, lighting of the pier at Port Esquivel is now fully solar powered, and plans are currently in progress to have the entire port solar powered. At Yuaton, plans are in place to have areas of the plant solar powered where possible. In Jamaica, we look forward to contribute to the net zero ambitions.
Hello everyone, my name is Stefan Beaulieu and I'd like to welcome you to Rusal Ornish Alumina Refinery based in the west of Ireland. It's a pleasure for us to give you an insight on our carbon journey so far, on what we've achieved and what we're planning to do to reduce carbon emission towards zero. Protecting the environment and surrounding areas have been a priority since the refinery is in operation. Some of the areas around the plant are European designated protected areas for various species and habitats. The plant has been in operation since 1983 and today produces over 1.9 million tons per annum of alumina. The alumina is mostly shipped to Europe for the production of aluminium. Oginish have a total of 650 workers on site, and the plant is one of the most energy efficient refineries in the world and currently the 4th lowest carbon emission producer per ton of alumina. This was achieved with high level of commitment to continuously reduce the energy requirement to make alumina and high level of investment to migrate from oil as energy source to 100% natural gas since 2014. Moving to renewable energy source is the next phase of our journey. Oginish alumina was designed in the 70s, and the only energy source available here in Ireland at the time was fuel oil. Temperature of up to 250 degrees centigrade is required to dissolve the alumina contained in the bauxite via a process called bare digestion, and temperature above 1000 degrees centigrade is required to calcine the product into alumina. These two processes are very energy intensive, and Oginish has invested very significantly over the years to improve its energy performance and reduce its greenhouse gas emissions. The conversion from fuel oil to natural gas was delivered with a major multi-year investment program which was initiated in 2006. It started here with this big building behind me. A new 150 megawatt high efficiency combined heat and power plant, or as we call it, CHP. The CHP plant supplies 300 tons per hour of steam to the refinery and 40 megawatt of electricity is produced to supply the plant equipment, with the excess power exported to the national electricity supply network. The electricity produced by the CHP plant is much lower in carbon content compared to the national average. CHP is still the lowest carbon technology after wind to produce steam and power in Ireland. CHP will remain the best technology until a renewable fuel is commercially available and economically viable to industry in Ireland, which is probably more than a decade away. On the calcination side, all 3 alumina calciners were fully converted to natural gas by 2012. And to complete the transition to natural gas, in 2014, 2 new gas boilers were constructed to replace the fuel oil boilers. In parallel to this fuel transition, many energy improvement initiatives were implemented in the refinery. With these investments and continuous internal energy improvement, carbon emissions have reduced by 40% in the last 20 years. Sulfur oxide emissions have reduced by 100%, and nitrogen oxide emissions by 90%. The next phase of our journey will be exciting and challenging, as we need to make major carbon reduction using technologies that are currently not commercially available. This will be done by improving process energy efficiencies such as recovering waste heat in all areas of the refinery and by moving towards using renewable energy sources. The wind is currently the most abundant renewable energy available, with over 300 wind farms in operation in the Republic of Ireland. Oginish plans to start producing steam to supply the refinery using electric boiler. We have been successful in a project grant application to install a 25 megawatt high pressure electric boiler. This boiler technology can ramp up and down very quickly depending on variation of wind power generation. The project will improve grid stability as well as providing steam to the refinery from renewable electricity in periods of wind generation. Electrification of our processes will play a significant role in our decarbonization roadmap, and it is possible for us in Ireland that green hydrogen and biofuels may become economically viable in the coming decades or so. In summary, Oginish is very well positioned to face the transition towards a zero carbon production of alumina.
An important part of our pathway plan is our continued commitment to our new energy program, which has been ongoing since 2007. The new energy program provides for large-scale reconstruction, replacement, and modernization of the main equipment at the company's Siberian hydropower plants: Krasnoyarsk, Irkutsk, Bratsk, and Ust-Ilimsk. Hydroelectric units are being retrofitted, and the turbine wheels, transformers, and outdoor switchgears are in the process of replacement. The modernized turbines also incorporate an up-to-date runner design that prevents risks of turbine oil leakage into water. As a result, we can ramp up the energy output from the same volume of water passing through the hydropower turbines. Upgraded equipment at our HPPs has already supported an increase in hydropower production of 1.7 terawatt-hours in 2020 and helped to prevent greenhouse gas emissions by approximately 2 million tons due to the partial replacement of prior thermal power generation volumes. We are on track to generate 2.5 terawatt-hours more electricity by 2025. The program will also allow to prevent emissions at least 2.5 million tons of CO2 from 2025 by replacing coal-fired power generation volumes with hydropower-generated electricity. Additional higher efficiency of up to 8% will result from the improved blade profile of new turbine wheels and the materials used. The modernized HPPs will become even safer and more reliable. We will also work to decrease losses during transmission of electricity. That means reducing losses to less than 5% of electricity supplied to the high voltage and low voltage grids by 2024. To ensure further transparency of aluminum carbon footprint, we decided to measure anthropogenic GHG emissions from HPP reservoirs, in line with the IPCC guidelines from national greenhouse gas inventories. The aim is to define and calculate Tier 3 emission coefficients for 6 HPP reservoirs in Russia that either fully or partially belong to the group: Irkutsk, Bratsk, Ust-Ilimsk, Krasnoyarsk, Onda, and Boguchany. As a part of our strategy, we will continue to conduct R&D on smart grids and solar energy, as well as construction of small HPPs.
I am Nikitin Evgeny Viktorovich, Chief Officer of Rusal Company. Converting half of the capacity at Krasnoyarsk, Bratsk, Irkutsk and Novokuznetsk smelters to pre-baked anode technology is planned for a period between 2025 and 2030. Once implemented, the program will also help massively reduce the smelter's emissions of fluorides and resinous substances, including benzopyrene. This will also reduce energy consumption by 11 to 18%. And of course, there is inert anode, our innovative technology. Here, the smelting process uses anodes that do not degrade during production, meaning oxygen is created as a byproduct rather than carbon dioxide and perfluorocarbons.
Even as early as this year, many of our industry peers and partners considered low-carbon aluminium as some sort of gimmick. The fact is that demand for low-carbon aluminium is growing across multiple key segments, This is only going to continue to grow in the years and decades ahead, driven by energy efficiency via lightweighting, as well as decarbonisation of products during their life cycle. That is because this versatile metal has a critical role to play in building the circular economy of the future, thanks to its unique properties and its infinite recyclability. Demand for aluminium is anticipated to grow by more than 50% by 2050, and the industry is constantly looking at pathways to reduce its carbon footprint, and we are leading the change in this process. Considering LCA, we estimate the current demand is 3.5 million tonnes per annum, and we anticipate this to grow tenfold to over 30 million tonnes by 2050. Whilst we are blessed with over 90% of our production coming from renewables, we aren't resting on our laurels. Thanks to the revolutionary new inner anode technology that Rusal is pioneering, we are making it possible to eliminate greenhouse gas emissions from the process altogether. When combined with renewable hydropower, inner anode technology provides an unprecedented low carbon footprint in metal production. And this is not hypothetical. Rusal has already successfully produced aluminium through the program with the industry's lowest carbon footprint, less than 0.01 tonnes of CO2 equivalent per tonne of metal. As a first mover in this groundbreaking technology, we have partnered with Ball Corporation to produce aerosols and other containers made from the world's lowest carbon aluminium. This truly represents the future possibility of sustainable aluminium products that go beyond our current low carbon capabilities by eliminating all greenhouse gas emissions during the production. Total decarbonisation of our industry has to be the goal, and we are showing the way forward. As a company, we are not yet 25 years old, and yet we produce about 6% of the world's aluminium, and we are the largest producer of low carbon aluminium globally. We already meet more than 90% of our energy needs through hydropower, and we're amongst the first aluminium producers to be rated A by the Carbon Disclosure Project. We signed the first ever sustainability-linked syndicated facility arranged by international and Russian lenders, representing a sum of over $1 billion US. And we're not afraid to stand out from the crowd. And the launch of our Allow brand in 2017 and related market developments of the low carbon segment illustrates our drive and initiative to do what is right for our industry. Rusal represents a force for change, whether it's engaging at the highest levels of government or advising the London Metal Exchange on its own sustainability initiatives with the launch of the LME Passport, or active membership of the industry associations such as the IAI, the Aluminium Association of America, or the Japan Climate Leaders Partnership. You will find us there, leading the industry forward.
Based on the results of pilot projects, we will consider green hydrogen as one of the ways of substitution for fossil fuel along the whole value chain. It is expected that green hydrogen will become cheaper and more readily available in order to support, for instance, alumina hydrate calcination and alumina refineries or heat and steam production necessary for the alumina production process. We anticipate that the main source of greenhouse gas emissions from alumina refineries will be eliminated by 2050. Global demand for clean hydrogen by 2050 is estimated to range from 539 million tons to 813 million tons, a tenfold increase compared with the current levels. Hydropower is the most mature, reliable and one of the most cost-effective renewable power generation technology available today. In terms of the availability of hydropower resources, Russia ranks second after China in the world, ahead of Brazil, Canada, India and the United States. However, use of hydro potential in Russia is significantly lower than in other countries. So, less than 20% of the hydro potential of Siberia and the Far East is currently channeled for energy production purposes. Untapped hydropower resources allow the development of green hydrogen production, and thus Plus Group is examining opportunities for large-scale green hydrogen production using electricity both from existing HPPs and captive new-built renewable projects, hydro and wind, both in Siberia and in the Far East. For example, We are exploring the construction of a 1 gigawatt Motyginska HPP on the Angara River, solely for hydrogen production. And thanks to the new energy program, we are able to explore green hydrogen production of up to 13 kiloton per year using the additional electricity output from our existing hydropower plants. Extra capacities are now available at Irkutsk, Bratsk, Ust-Ilimsk HPPs. The company also considers to use electricity generated by the Anode HPP in Karelia to produce green hydrogen. Total capacity considered for hydrogen production is estimated up to 228 megawatt, with export potential to South Korea, Japan and Finland. Additionally, since storage and transportation are key issues for developing the hydrogen industry, N+ Group, together with an already approved tank container manufacturing partner, intend to develop aluminum tank containers for road, rail and sea transportation of liquefied hydrogen. The group is also examining numerous pilot projects in the hydrogen field, one of which focuses on the development of a concept for hydrogen transport infrastructure for Krasnoyarsk. The project consists of the construction of a small-scale green hydrogen electrolyzers using carbon natural electricity from the Krasnoyarsk HPP, which is planned as a fuel for hydrogen fuel cell buses. The company has a very small carbon footprint of purchased electricity, as around 98% of our power for electrolysis comes from hydropower plants and other low-carbon generators. By 2040, we expect that we will reach close to 100% of power consumption from the grid from carbon-free source by using market mechanisms such as power purchase agreements and renewable energy certificates such as IREX. As of mid-August 2021, N+ Group has roughly 60% share of the Russian market in terms of delivered IREX and is active in securing new contracts for future deliveries. Finally, greenhouse gas emissions that cannot be eliminated by current existing technology through modernizing and adapting the production processes. Such emissions need to be compensated through technical and nature-based solutions. Technical-based solutions comprise carbon capture, usage and storage, or CCUS technologies. CCUS requires the creation of appropriate CO2 gas compressing and transportation infrastructure that would facilitate capture of concentrated CO2 from emissions and transport of this concentrate to places where it would be possible to utilize or store this carbon. For example, in underground storage or in other spaces that would ensure the carbon doesn't escape. Our calculations suggest that we can capture and utilize or store around 7 million tons of CO2. Nature-based solutions are solutions that allow the capture and storage of CO2 through natural processes. The group has implemented extensive forestry projects. In 2019, N+ Group, together with the Russian Federal Forestry Agency, or Roslesхоз, and regional ministries, began developing a plan for what at the time was the largest forestry initiative in Russia. Since 2019, we planted more than 1 million trees for reforestation of Krasnoyarsk territory and Irkutsk region in areas devastated by forest fires the preceding years, and have provided aerial fire protection in the Krasnoyarsk territory. For detail on everything in this webinar, plus industrial crypto mining and data center projects, pilot charging stations for electric vehicles, and other activities to support our communities, please refer to our report.
Publishing the Pathway to Net Zero report is part of our continued commitment to transparency. The report discloses the sources of emissions, the time frame for achieving net zero, the amount of abatement and plant neutralization. Also, our interim targets and milestones. The group both discloses its own emissions and promotes industry-wide disclosure. In 2017, our metals segment Rusal was the first aluminium company to include the externally verified carbon footprint of its products into commercial contracts. As part of our 2050 net zero journey, we will go further so our customers can make informed decisions for product design and materials sourcing. We will share our expertise in carbon footprint calculation methodologies and disclosures, environmental product declarations, and digital traceability of the metal. We have been vocal on this for some time now. Since 2019, the group has urged the London Metal Exchange to show greater green ambition with its sustainability proposals. We have recommended fully integrated mandatory carbon content and sustainability-related disclosure into the trading system. We welcome the LME's first step towards carbon transparency, the introduction of the LME passport, a voluntary digital credentials register. We further urge the aluminium industry to unify the measurement and disclosure of the carbon footprint of all products. Currently, the industry doesn't even have common carbon footprint assessment methodology. That said, we are far from alone on our journey. We join forces with other industrial players. We collaborate with national and regional governments and academia, as well as communities, to identify joint solutions. Our carbon footprint is assessed in line with the relevant ISO standards and the International Aluminium Institute's 2018 Carbon Footprint Technical Support document. Our carbon footprint is traceable to individual smelters. We support the Aluminium Stewardship Initiative, and we have been members of the International Aluminium Institute for almost 20 years. Our metals business, Rusal, has been involved in the Carbon Disclosure Project since 2015, receiving an A- in 2020, marking the first time an aluminium producer has received such a high rating from CDP. EN Plus Group and Rusal are the only two Russian members of the Carbon Pricing Leadership Coalition, and in 2021, Lord Barker became one of the two CPLC high-level assembly co-chairs. We support the Paris Agreement and endorse and align our activities with the global climate change goals outlined in the United Nations Framework Convention on Climate Change. We are actively involved in the United Nations Global Compact and the World Business Council on Sustainable Development, through which we advocate for decarbonization of our sector. In August of 2019, EN Plus Group joined the Science Based Targets Initiative and Business Ambition for 1.5 degrees. We are also active in the drive towards the energy transition.
Thank you for staying with us as we've navigated our way through this important report. But I genuinely believe our pathway to net zero is actually an inspiring read. It's become increasingly clear that getting greener is also making us more efficient, more competitive. There is indeed a compelling business and economic case for us as a group to lead the low carbon transition. This in turn opens the way for innovative, low carbon products to become lower cost and more competitively priced for every global consumer, so more people can buy them. And as businesses, we must all play our part in the fight against climate change and accelerate towards a low-carbon economy. But governments can also do more. In particular, we need policymakers to embrace green free trade. We need the permanent suspension of import tariffs on all products with a low-carbon content, especially a material as essential as low-carbon aluminium. Green free trade is an easy shortcut to a low-carbon future. Sustainable businesses the world over need access to our vital green metal. Aluminium is incredibly strong, lightweight, non-corroding, and endlessly recyclable. Aluminium plays a vital role in the green energy transition. We simply can't build a low-carbon economy without low-carbon aluminium. So now more than ever, it is the material of the future. And if we follow this plan outlined today, we can get there.